Welcome geometry students to class today on this Tuesday the 12th. Hope you guys are doing well. Hope you're ready to learn some math today. Let's see, today should be opening day for any of you that are on the basketball team, girls or guys, so hope you guys do well today. I'm not sure, Azu, if you're playing basketball. I know you play soccer, and Jace, I don't think you're a basketball player, but if any of you guys are, hope that you have a good first game of the season tonight. Let me turn my Mimeopad on here, and let's take a look at some announcements real quick here. First of all, there will be a quiz tomorrow, and we're going to go over what's going to be on that quiz in just a second, and so be ready for that. You might want to get out some pen and paper or something to write on while I go over what's going to be on the quiz tomorrow. This is what you owe me from yesterday, page 306, 8 through 23 all. I believe 2 of you turned it in. Now I'm going from memory, and for me it's a pretty scary thing to do. It seemed like Jake and Azu already turned this in, but I could be wrong. So if I'm wrong, don't panic, okay? I'm just saying I know 2 of you did. I'm pretty sure it was those 2. So the rest of you, go ahead and turn your homework in now at this time. Haley, I'm not sure who your supervising teacher is during third hour, but please turn that in. And you'll have to get used to me, Haley. I know that I'm a new teacher to you, but students, if you don't turn your homework in, I am going to contact your parents every night and let them know. It's got to be turned in, okay? Jace, I got your note that you wrote to me on top of your homework. I hope we're getting things taken care of. I believe you owe me I'll check Sycamore and try to let you know tomorrow what other assignments you owe me. You turned a couple in. I recorded those. Your Sycamore account is totally updated, and tomorrow I'll go ahead and throw a couple more up there that you need to turn in if there are a couple, and you can look yourself on Sycamore if you want to. Test Wednesday and Thursday if at all possible. If there's any problem with that, just call me or email me and talk to me, okay? I can work with you as long as you're contacting me and talking to me, okay? Now the quiz tomorrow, of course, JC, you're welcome to skip if you want to, and you might not want to. You might be surprised how easy it is, okay? So that's totally your decision. Now let's go over the quiz. I'm going to use some previous slides so you can just take some notes here. Let's go to 5.6. Let's see here. I'm not going to give you any fill in the blanks on the quiz, okay? So understand that right now. I'm going to give you some problems like this here. Are you ready? I'm going to give you problems where this segment, well, first of all, where a line and a line intersect like that in such a way that this line here is congruent to this line here, and we have a right angle here and here. And when that happens, we know for sure that this segment here is congruent to this segment here. So I'm going to give you some problems like this. Like in that example there, it would be 2x plus 5 equals x plus 10. Okay, and then you would solve for x. And then once you solve for x, you're not done. Then you want to find the length of EF. Okay, so we did these. This is lesson 5.6. If you want to make note of that as you study for your quiz tonight, page 274, number 3 at the bottom. This will be a good example for you to look at, and there are some other problems in that section you can study. Okay, I think that's all I want. Yeah, that's it from that section there. And then 5.7, which is right here. That shouldn't be right. Here's 5.7. This is the lesson here where it was all about symmetry and reflection. Like here I asked you, is A a reflection or is red a reflection of blue? And pretend in your mind you folded this piece of paper over right on this line. If you folded it, this point would definitely fall on top of this point, and this point would fall on this point, and this point would fall on this point. So yes, in this case the red triangle is a reflection of the blue triangle, and we say it's reflected on line M. Reflected on line M, because that's the place that it's being reflected over. And then here you would say no, red is not a reflection of blue, because if you were to fold this paper over right here, the blue triangle would land here, here, and here. That's where the blue triangle would land. It would not land on top of the red triangle. So be able to tell me tomorrow no or yes these figures are reflections of each other or they're not. Okay, and I think that's pretty much it. I did ask you to tell me when a segment or something is reflected on the x-axis or reflected on the y-axis, and that would also be fair game for your quiz tomorrow. And notice these page numbers you can write down and study problems from that section. Okay, so any of these would be good for you to study. Anything like that in the homework section too. Okay. All right, and then let's see what else we got here. This is yesterday. I'm not going to give you any fill in the blank like I said. So the main thing is I very well could ask you not words like what is a vertex, but I might give you a figure and say tell me what the vertices are. Like in this triangle here, the vertices are A, B, and C. I could ask you something like that. I could also ask you to draw a diagonal, or something like that, or what is which one of these lines is a diagonal. So I'm not going to ask you to fill in the blank, but be familiar with what a diagonal is. Then I'm definitely going to give you some of these where I give you figures and you say yes, they're polygons, or no, they're not. Okay? And that's basically it. No, that's not it at all. And then I'm going to give you some problems in which you have to find missing angles in quadrilaterals, because we know the interior angles of quadrilaterals always add up to 360. Okay, so problems like that, or even some with some x's like that would be fair game. Now Jay said there's no pressure either way, but you can see it's not a superbly hard quiz, so it might actually help your average if you do really well on it. So it's up to you. And actually, here's something else, and don't feel any pressure to do this, Jasa. I really don't care. It's totally up to you, but you can take the quiz, and if you don't do well, I just won't count it. All of that's up to you, okay? Students, let me grab a quick drink of water, and let's go ahead and get started, okay? Please get out your notebooks, your pens, pencils, books, calculators, and I will teach as quickly as possible so you can get started on your homework tonight. And by the way, it's going to be a homework assignment you've never done before, so it's going to be interesting. I don't think you're going to like it very well, but we'll cross that bridge at the end of the class period. Here we go. Let's review for a second. Don't write this down. The other day we learned that a polygon is a plane figure that's formed by 3 or more segments called sides. Each side intersects exactly 2 other sides at its endpoints. Just a little review. We learned that a vertex is the endpoint of a polygon. So if I have a polygon that looks like that, all of these endpoints here would be the vertex. Okay? All of these endpoints of segments would be the vertex. Okay? So all of those are vertices. A diagonal, we talked about a diagonal is any line that connects 2 non-consecutive vertices, so that would be a diagonal. That would be a diagonal. Well, kinda. Not a very good drawing. Let's see. That would be a diagonal. That would be a diagonal. That would be a diagonal. Anytime that you connect 2 vertices, as long as they're not 2 vertices side by side, you have a diagonal. And then know this, and this is something you need to know. We learned this yesterday. The sum of the measures of the interior angles of a quadrilateral is 360. Okay? So, just a quick review of what we learned yesterday. Let's go ahead and take some notes now. Please copy this in your notes. We're going to start studying now quite a bit of stuff here on parallelograms. In fact, we're going to spend the rest of the week on parallelograms. Okay, so the rest of the week we're going to be studying parallelograms, different things about that, so understand that, and I think you'll find it pretty interesting. Lesson number is 6-2. The date today is the 12th, and we're going to start off today looking at properties of parallelograms. Properties of parallelograms. All right, so here we go. Would you please copy this in your note? The very first thing we need to do is establish what a parallelogram is. So write this in your notes. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. A parallelogram is a quadrilateral. Now that's a 4-sided polygon. A quadrilateral, a 4-sided polygon with both pairs of opposite sides parallel. That is the definition of a parallelogram. So I would like you to go ahead and copy this in your notes if you would, please. that would be a parallelogram, okay? I put an arrow on this line and an arrow on this line, and that means this side is parallel to this side. And then I'm going to put 2 arrows on this side, 2 arrows on this side, and that means this line here is parallel to this line here, or this side here is parallel to this side here. Okay? So there you have it. That's a parallelogram. A parallelogram is a 4-sided figure. This has 4 sides with both, not one pair, both pairs of opposite sides parallel. So this side must be parallel to this side, and this side must be parallel to this side. Okay? So that is a parallelogram. You need to know that. Now, I want to talk to you about some characteristics of parallelograms. And actually, you just learned one, didn't you? You sure did. You just learned that both sets of opposite sides will always be parallel. So if I tell you that you have a parallelogram, then you know right away that both pairs of opposite sides are parallel. All right? Please copy this theorem in your notes. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So if we have a parallelogram, then we know for sure that its opposite sides are congruent. Very good. Here we go. Would you please copy this in your notes? I want you to very quickly draw a parallelogram. Now, I'm telling you this is a parallelogram right here, so I'm not going to mark all the sides parallel like this, okay? But what I am going to say is this. This side here will always be congruent to this side here, and this side here will always be congruent to this side here if you have a what? A parallelogram. So, in other words, if I knew this side here had a length of 8 and this side here had a length of 11, I could find the other 2 missing sides. This side up here would have to be 11 and this side right here would have to be 8. So opposite sides are congruent as long as you have a what? A parallelogram. And by the way, if you think of it, you know what another type of parallelogram is? Isn't a rectangle a parallelogram? Well, you tell me. Is this side here parallel to this side here? Yes, it is. Is this side here parallel to this side here? Yes, it is. So a rectangle, by the way, is a parallelogram also. Okay? But anyways, let's continue on. Let me grab this thing here and drag it over here. Alright, so the first character trait you need to learn about parallelograms is opposite sides are congruent. Let's go ahead and very quickly solve this problem. I don't think you need to take notes on this, so please don't, unless you really want to. If you want to write down page 310 example 1, please feel free to. But to me, it's self-explanatory. As soon as you see 2 arrows here and 2 arrows here, you know this side's parallel to this side. And as soon as you see 1 arrow here and 1 arrow here, you know this side here is parallel to this side here. All right? So, because we know we have a parallelogram, we know opposite sides have to be congruent. So if this is 3 over here, and by the way, what we're trying to do, I should have told you, is we're trying to find the length of JF, and we're trying to find the length of JH. Well, if this side right here is 3, then JF also has to be 3, and if this side down here is 5, then JH also has to be 5. As soon as you know that you have a what? A parallelogram, then you know right away the opposite sides are congruent. Okay? Pretty simple. Not difficult at all. Alright? And again, you don't need to take notes on this. If you want to write down page 310, number 1 at the bottom, you can. I think you guys are totally getting this. I don't think it's that difficult at all. AB would equal blank. AD would equal blank. Well, by the way, first of all, I have to mark parallel sides here. If I don't, you don't know that you have a parallelogram unless I tell you you have a parallelogram. Okay, as soon as you see those parallel line symbols, you know that you have a parallelogram. And so we know that if this side over here is 9, then AB also has a length of 9. And if this side right here has a length of 8, then I know this side up here also has a length of 8, so AD is 8. Okay? So there we go. Whenever you have a parallelogram, opposite sides are congruent. Now, here's another character trait we're going to learn today. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Opposite angles are congruent. Now, if the word opposite confuses you, I would allow you to use the word diagonal angles are congruent. I don't care, as long as you just know what you're doing, okay? But if you have a parallelogram, and I'm telling you now this is a parallelogram, then the opposite angles are congruent. So if I know this angle right here, whatever this angle is, and you might want to write this in your notes here, this drawing, I know this angle right here is going to be congruent to this angle. And this angle here will always be congruent to this angle. Now you know this as soon as you know that you have a what? A parallelogram. Opposite angles are congruent. Got it? Opposite angles are congruent. So, copy this down. If a quadrilateral is a parallelogram, then its opposite angles are congruent. And then there's one other theorem. I didn't give you any problems yet to work out for theorem 6.3. There's one other theorem I want to talk about. We're going to look at more than just this, but I want to do another theorem before I get into some problems. And here it is. This is probably the toughest one to understand. So would you please listen carefully and give me really big ears right now and listen, okay? If a quadrilateral is a parallelogram, in other words, if we have a parallelogram, which I'm telling you now, we have a parallelogram. So if a quadrilateral is a parallelogram, then its consecutive angles are not congruent. Nuh-uh. They are supplementary. Now we know this angle here and this angle here are called opposite or diagonal angles. And we know this angle here and this angle here are called opposite angles or diagonal angles. However, what do we call two angles that are side by side, like these two? Or what do we call these two angles here that are side by side? Or what do we call these two angles here that are side by side? Or what do we call these two angles up here that are side by side? Well, you've guessed it by now. We call them consecutive angles. And if you have a what? A parallelogram, then you know that angles that are side by side or consecutive angles are always going to add up to 180. Remember, that's what supplementary means. It means the sum of the angles is what? 180. Okay? So now you know something else about the angles of parallelograms. We know that opposite angles are congruent and consecutive angles are supplementary. Please don't forget that. We also learned today that opposite sides are congruent. Now this is all true for parallelograms. Let me get a quick drink of water here. Okay, and let's continue on. Now, let's start doing some problems. Here's what I would like you to do. I would like you to find the measure of angle Q. I do want you to write this one in your notes, please. And I want you to find the measure of angle R. And I want you to find the measure of angle S. Now, if you don't want to draw this picture in your notes, you can just make a note that we're on page 311, example number 2. Now, let's go ahead and do the easy math first. We learned 2 theorems ago, opposite angles are congruent. So, if this is 70, go over here diagonally or opposite, and we know that angle R must also be 70. So that's easy. There we go. Now, in the last theorem we had, we just learned that consecutive angles are supplementary. That means they add up to 180. So if this is 70, then this angle here has to be what? Wouldn't it be 110? Because 110 plus 70 is 180. And how did I know that? Well, if this angle is 70, if I just take 180 and subtract 70 away from it, I'm left with 110 degrees. So because these two angles here have to be supplementary, then if this is 70, this has to be 110. Now, once we label angle Q 110 degrees, remember diagonal or opposite angles are congruent if you have a parallelogram, and angle S then would have to be 110 degrees. Pretty cool, huh? So how did I know we had a parallelogram, by the way? Because I have 2 arrows here and 2 arrows here. That means this line is parallel to this line. And then also, I have one arrow here and one arrow here, so I knew this line here was parallel to this line here, and that's the definition of a parallelogram: a four-sided figure, quadrilateral, that has both pairs of opposite sides parallel. Okay, so I knew I had a parallelogram, thus I knew I could apply all of the angle characteristics that we have learned today. All right, moving on to this one here. Why don't you go ahead and try it on your own if you want to. I'll kind of pause a second while you're getting turned over in your books to page 311, number 2 at the bottom. Or if you're just copying this in your notes, whatever you choose to do. I'm just going to I'm not going to pause the video, just let the video run, but I'm going to give you a second to go ahead and try to find the measure of angle B and the measure of angle C and the measure of angle D. Give you just a second to do that, okay? Okay, here we go. Let's do the easy math first. If this angle is 60, if I go diagonally across to the opposite angle, angle C is also 60. So there we go. And then consecutive angles are supplementary. I have a 60 here and a 60 here. So this angle right here has to be 120, right? Because 60 plus 120 is 180. Or you can look at it like this. Here's the 60 down here. 60 plus 120 is 180. So angle B has to be 120 degrees. And then if I go straight across to angle D and angle B have to be congruent, and so angle D would also be 120 degrees, just like angle B. So we're just applying characteristics that we have learned of parallelograms, okay? Now, I think we're just about done. Yep, just about done. So here we go. Hang in there. Last theorem we're going to learn today, last one. If we have a parallelogram, if a quadrilateral is a parallelogram, now listen carefully, then its diagonals bisect each other. That does not mean that the diagonals are congruent. They are not necessarily congruent. Let me say that again. This theorem is not saying that this diagonal here is congruent to this diagonal here. That's not what it's saying. It's saying they bisect each other. In other words, this segment here is always going to be congruent to this segment here, and this segment here is always going to be congruent to this segment here. That is, of course, as long as we know that we have a parallelogram. We have to make sure that we have a parallelogram. Okay? And we do have a parallelogram. So if a quadrilateral is a parallelogram, or in other words, if you have a parallelogram, then its diagonals bisect each other. They cut each other in half. So this segment will be congruent to this segment congruent to this segment. Okay? All right, continuing on. So with that in mind, I want you to find the length of xt. Please find the length of xt. Now, I am going to go ahead and say that we have, oh, there's a symbol. Remember how we do, like, if it was triangle ABC, students, we would put triangle ABC. Well, there's a symbol for parallelogram I wanted to show you guys that we use in geometry. And it looks just like that, okay? So parallelogram UVWT. It doesn't matter what letter you start with, but you go in order like this, clockwise. So we would call this parallelogram UVWT, or you could call it parallelogram VWTU, or you could call it parallelogram WTUV, or you could call it parallelogram TUVW. Either way, all of those are fine, but we do have a parallelogram. So parallelogram UVWT. I want you to find the length of xt. Now, I just said we have a parallelogram. I just said that. And a minute ago I said that when you have a parallelogram, the diagonals bisect each other. So if that's true, then what that means is this segment here is congruent to this segment here, and this segment here is congruent to this segment up here. So let's see if that helps us. We're trying to find the length of xt. Now, look at this. The length of Vx, that segment right there, is 3. Vx is 3. So if this segment right here is 3, then that means this segment down here also has to be 3, because in a parallelogram, diagonals bisect each other. So xt would have to be 3. Xt would have to be 3. Okay, moving on. Now this will be interesting here. Let's see if we can figure this out. UW, this entire diagonal, is 30. The whole thing is 30. And ux, right here, ux is 2x plus 3. I want you to, now this is not in your book, so please write this in your notes. I feel like it's very important for you to have this in your notes, okay? I want you to solve for x. Solve for x, okay? So here we go. Now let's stop and think about this and use a little common sense, if we could, please. Now, I know the entire length from u all the way down to w is 30. The whole thing's 30, right? But I also know this. I know that, oh, by the way, sorry, my fault. I want to go ahead and state now we do have a parallelogram. We have parallelogram UVWT. Sorry about that. So we do have a parallelogram. So as soon as I realize we have a parallelogram, I realize my diagonals bisect each other. So I know this diagonal is, that segment is congruent to this segment, and this segment is congruent to this segment. So I do know all of that. So I'm saying let's think this through here. If UW, that whole thing is 30, if I cut that in half, that'd be 15. That means UX is 15 and WX is also 15, correct? If the whole thing UW is 30 and we know that it's cut in half, then this has to be 15, this has to be 15. So UX is 15 and UX is also 2x plus 3. So they're equal. I can say 2x plus 3 equals 15. Bring the 3 over and make it a negative 3. If you do that correctly, you'll have a 12 here, and then divide both sides by 2. And there you solve for x. Pretty cool, okay? So when you have a parallelogram, diagonals bisect each other. Diagonals bisect each other. Now let's very quickly review. You're welcome to take notes on this. You don't need to if you don't want to. It's totally up to you. Just make sure that you make a good decision and that you're understanding all of this math. Here we go. All right. Characteristics of parallelograms. Opposite sides are parallel. Opposite sides are parallel. Opposite sides are congruent. Opposite sides are congruent. Opposite angles are congruent. Opposite angles are congruent. Consecutive angles are supplementary, not congruent, supplementary. And then last but not least, diagonals bisect each other. So if I have a diagonal here and a diagonal here, this segment is congruent to this segment and this segment is congruent to this segment, okay? The diagonals bisect each other. Now, you're not going to like this very well, but I've become very concerned with your fill in the blanks. That far and away, that's where a lot of you are missing your points. So tonight, I'm not giving you any homework, okay? No homework. You're going to come into class tomorrow on a Wednesday, and you're going to take a quiz, and then you're going to work on homework from this lesson the whole class period tomorrow. When I say no homework, though, I mean no math homework. I want you to turn to page 312 and look at the bottom. And at the bottom of page 312, I did not take a picture of it, but I felt like you guys are old enough students to handle this. Please turn to page 312 and look at the bottom. It says Summary Properties of Parallelograms, and it has 5 phrases written out. Definition of parallelogram, Theorem 6.2, Theorem 6.3, 6.4, 6.5. I want you to write all of those phrases 3 times each. Yeah, I know I'm not winning a popularity contest, but I used to do that at Tennessee Temple with all my geometry classes, and last year and this year I have yet to do that, and I really feel like we need to get back into that, and we're going to be doing that more and more, if not every day. So, I want you to write out the definition for a parallelogram 3 times, write out Theorem 6.2 3 times, I want you to write that out 3 times, write out Theorem 6.3 3 times, write out Theorem 6.4 3 times, and write out Theorem 6.5 3 times. Okay? So write out each one of those 3 times. Now here's what I want you to do. Are you listening? Please don't get confused. Do all that work, but do not turn it in. Actually, you can turn it in if you want. That's fine. I was going to say put it together with your homework, but I really don't care either way. So you need to work on that now. If the bell is not rang, I want you to go ahead and work on it now until the bell rings. and it is due tomorrow. So when you come into class, I am going to ask you to turn that in. So it is due tomorrow, or you're going to lose points or whatever. So please turn it in tomorrow and put your name on it and copy those 3 times each. And then tomorrow in class, when you come into class, we're going to take a quiz, and then you're going to watch a homework video. Okay? All right, call me or email me if you have any questions at all. I hope you guys have a great day, and I hope you're ready for your quiz tomorrow.